So your first exam will be in the first week of March on March 4th. And before the first exam, you will have one more quiz. And I am planning to give you the quiz next week, maybe next Thursday. So I will send you an email about this. Okay, so in the last class, actually, we didn't have class on Tuesday. So in the class last week, so we finished section 3.1 and we discussed about probability mass function, probability distribution for discrete random variable. So we'll continue our discussion about discrete random variable and its probability distribution. So in the last class, we discussed about one form of discrete probability distribution. So where we discussed the tabular form of the probability distribution. So so we listed the values of x random variable. Yes, any question? Okay. So in the first column, we listed the values of x, and in the second column, we listed the corresponding probabilities. So the probability distribution means we will list the values of x and their corresponding probability. So we can do it in tabular form, or we can also do it using graphical representation, or we can also use function for probability mass function. So usually we denote the probability mass function by f of x, or you can also use p of x, or we can also use g of x. Here, this is function, and this is function of random variable x. And for discrete random variable, it is called probability mass function, or PMF. And for continuous random variable, and we'll discuss about this in the next chapter. And in continuous case, this is called probability density function, and which is also called PDF for continuous random variable. But since this is discrete random variable, this is called probability mass function, and it is denoted by PMF, and the function is denoted by f of x, p of x, or g of x, or you can also use some other notation. So we'll go over an example now. So this example is about Bernoulli probability distribution. So what is Bernoulli distribution? If in an experiment, if we have just only two outcomes, for example, if we toss a coin, then we'll have only two outcomes. Either we'll have head or tail. So if we consider head as success, then since for tossing a coin, we have only two outcomes. So if we consider H as success, then the value of X will be 1. And if we consider tail as failure, then the value for T will be 0. And we already discussed how we assign the value for different outcomes for the random variable. Okay, so for Bernoulli case, the random variable has only two possible values. So it has only two possible values here, either 0 or 1. Oh, okay. There is a question, where can we find the notes for the chapter 3? Oh, I'm really sorry about that. I didn't post the note on Blackboard for chapter 3. I'll do it today after the class, okay? Yeah. So for Bernoulli distribution, for the random variable, we'll have only two values. So x will have only values either 0 and 1. So, and here we denoted the function by p of x. So p of x is equal here 0.2 if x is 0. So if the value of x is 0, then the probability is 0.2. And if x is 1, then the probability is 0.8. And you already know that the total probability for all possible values of x, the total probability is always 1. So now if we add this to probability, then you will see that 0.2 plus 0.8 is 1. So for the other values of x, if you consider any other values of x, for example, if you consider x equal 2, 3, 4, 5, 6, 7, 8, 9, or any other values, the probability will be 0, because we already have the total probability 1. So for the other values of x, we cannot have any positive probability, because if we have more probability, then the total probability will be more than 1, then it will not be a probability distribution function. Okay, so that's why we say the otherwise the value is of f of x or p of x is 0. Okay, so do you have any question? Yes, go ahead. Any question? Okay, so this is called probability mass function, and for cumulative distribution, so this is called CDF. So this is actually probability distribution function will have the values of x and their corresponding probability. And for the CDF, CDF is different from the PMF or PDF. The CDF is denoted by capital F of x. Usually we denote it by f of x. We use this notation. And this means f of x is equal probability x less than equal x. This is actually cumulative probability. So if the value of x is, for example, if the value of x is 3, then f of 3 means, that means CDF f at 3 is equal probability of, for example, if the value of x is 3, then it will be x less than equal 3. So that's mean we'll add all the probabilities up to the value of x is equal 3. So that's mean the CDF is actually the cumulative probability. We'll add the probability for the value of x, and the maximum value of x is here. Since we consider 3, the maximum values of x will be then 3 here. So now I will discuss about some notations here, and you should know all of this. So in number 1 here we have, if for a less than equal b, if we have just two number a and b, and a is less than equal b, then the probability of a less than equal x less than equal b, you can find this probability, or you can calculate this probability by using CDF function. And for CDF function, you have to, this probability will be equal f of b minus f of a negative. So a negative is not negative a. So this notation actually different from negative of some number. This is not negative of a. So this means the largest value of x is strictly less than a. So what does it mean by strictly less than a? For example, if we want to find the probability between, for example, if we want to find the probability between x less than equal, for example, 5, then if you use the CDF function, then you can calculate this probability by using CDF, and then the probability will be f of 5 minus f of 2 negative. So what does it mean? That's mean from the CDF function, you will find the value of f for x equals to 5. And for this one, for 2 negative, you will find the value of f for x where x will be less than 2, not exactly 2. So the largest number of x which is less than 2. So we'll go over some example and it will be more clear to you. Okay, so and in number 2, probability of x greater than equal a, you can also use CDF function to find this probability. But to find this probability, you have to first rewrite this one as 1 minus probability of x less than equal a. So what we are doing here, actually, we are taking the complement. We know that the total probability is 1. So we are looking for the probability of x greater than a. But using CDF function, you cannot directly find this probability. So if you have x is greater than some number and you want to find the probability, then to find this probability, you cannot directly find this one by using CDF function. So because CDF function is always give you the probability less than some number. Because if you look at the definition of the CDF function, then you see that f of x is equal probability of x less than equal x. So that means it will always give you the probability for where x is less than or equal some number. But here we want to find the probability where x is greater than some number, greater than a. So you cannot directly use CDF function to find the probability. First, you have to rewrite in such a way so that the probability will become less than some number. So here you can see that 1 minus probability of x less than equal a. Now for this part, probability of x less than equal a, you can use CDF function because this is simply f of a. So you can directly use CDF function now. So when you have this type of probability, the greater than type of probability, first you will rewrite this one as a complement. So what is complement here? So we are looking for the probability x greater than a. So this is actually the complement of probability of x less than equal a. And the total probability is, because so x greater than a, so the values of x will be either greater than a or less than equal a, right? So for example, if you want to find the probability x greater than 2, okay, the values of x, values are, since this is discrete distribution, so x can take the values 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, any values. Okay, so probability of x greater than 2. So x has actually two type of values. So x, whether x will be greater than 2, and if you take the complement of this one, then it will be the values which are less than or equal to. So that's why here we wrote 1 minus probability of x less than a. This is actually the complement of this notation. Okay, so and we'll go over some example and then it will be more clear to you. So let's go over and so we have another notation here. So probability of x less than equal a, not strict, sorry, greater than equal a, not strictly greater than. So in this case, you have to also use complement because this is notation is greater than equal. So you already know that for this type of probability, you cannot directly use the CDF function. So in this case, first you have to write the complement in terms of complement, then you will use the CDF function to find the probability. Okay. So now I'll go over an example. Here, this example is about flip a coin 3 times and let x is equal the number of tails. So x is the number of tails and we tossed a coin 3 times. So, and we have to first write the probability distribution, which we have already done in section 3.1. So the possible values for x are 0, 1, 2, 3. Why 0, 1, 2, 3? Because the possible outcomes are HHH, HTH, or THH, or TTT. So the maximum number of tails, so each outcome, one outcome has maximum 3 tails and minimum 0 tails. So the possible values of x are 0, 1, 2, 3. So that's mean, and we have also some more outcomes. We'll have total 8 outcomes. So X can have 0 because when an outcome has no tail, so that's mean the value of X is 0. X, the maximum value of X can be 3 because X, the outcome can have maximum 3 tails. So that's why we have here the possible value 0, 1, 2, 3. And here we have the corresponding probability. So we have total 8 outcomes, and out of these 8 outcomes, one outcome has no tails. So the probability is 1 over 8. And when X is equal 1, the probability is 4 over 8. When X is equal 2, the probability is 7 over, oh, actually, this is not the probability. This is actually cumulative probability distribution. This one is the probability distribution. So the total probability will be 1. So if you add them together, then the total probability is 1. So now the question is, how did we calculate the cumulative probability? So the cumulative probability actually is better if you use notation the capital F of X for this one, because usually we use capital F of X for cumulative probability distribution. Okay. So why the cumulative probability for X equals to 0 is 0.125. So how do we calculate the cumulative probability? So if we want to find F of 0, so that's mean this is probability of X less than equal 0. So how many values of X we have here which are less than equal 0? We have just one value, right? So that's mean it will be just probability of X is equal 0. And in the probability distribution, we have when X is 0, the probability is 0.125. So how did we get the second one when X is equal 1? How did we calculate the CDF? If X is 1, then the CDF will be probability of X less than equal 1. So whose values are less than equal 1? Anyone? 0 is less than 1, right? So X is 0 plus, do you have any other values?
P of 1.
Yes, P of 1. You're right. Thank you. Yes. So now we have to add these two probability. So if you add 0.125 and 0.375, then it will be 0.5. So that's why the cumulative probability at X is equal 1 is 0.50. Similarly, we calculated the cumulative probability at X is equal 2. So f of 2 means probability of X less than equal 2. So that's mean you have to add the first 3 probabilities. And when X is 3, the cumulative probability you have to add all 4 probabilities. Then total probability is 1. So in cumulative probability distribution, the final one, the last value of f of X will be always 1 because you are adding all the probabilities and you know that the total probability is 1. Okay, so to find the probability, you can either use the cumulative distribution function if you have, or you can use the probability distribution function. So now the question is, if we can use the probability distribution function, then why do we need cumulative distribution function? Because the cumulative distribution function here, it will make your life easier because you can directly, if you have the cumulative distribution function, you can directly find the probability. So you do not need to add some numbers, or so it will be actually less time consuming. So for example, here we have in number A, probability of X less than equal 2. So we want to find the probability where X is less than equal 2. So since we have both probability distribution and the cumulative distribution, so either you can use the first table or you can use the second table. So if you want to use the second table, so that's mean for probability of x less than equal to, so that's mean x is 0 plus probability of x is equal 1 plus probability of, this is plus, okay, so plus probability of x is equal to. Okay, so that's mean you have to add these three probability. So this is one way. So you can see here, then the probability will be 0.875. So here you had to do some calculation. But if you have the cumulative distribution function, you can directly find this probability. So probability of x less than equal to, so from the definition of CDF, we already know that this is equal f of 2, right? Because this is less than equal. So this is equal f of 2. And you can see here, this probability is 0.875. So from this,
No, this chapter altogether.
yes, yeah, we have the numbers all together. Yeah.
I like, what's the name of this chapter altogether?
Sorry.
Like, what's the name of this chapter? Like, what's the name of this chapter we're working on? Like, what's the name of this chapter we're working on altogether?
Could you please type your question? Sorry, I'm not maybe for the network.
All right, so what's the name of this chapter we're working on altogether?
If you don't mind, could you please type your question? Okay. So no, I'm sorry about that. Could you please type your question? Oh, okay. So this is actually discrete random variable. Yeah, good question. So yeah, in the last class we talked about this. So this chapter, now the name of this chapter is discrete random variable and its probability distribution. So we are discussing about the random variable, and this is a particular random variable which is discrete and its probability distribution. Did you get your answer? Okay.
After, could you send me the class key? I'll not be able to log into WebAssembly because I lost my password. I wanted to ask if you send me the class key for the.
Oh, okay.
For
Okay, so I have already emailed you, so you can check your email. Okay. So
yeah, thank you.
okay. So probability x less than equal to, so which is you can use the PMF function or you can use the CDF function. So in part B, okay, so I should erase this part. Okay, so in part B, we have probability x less than 2. So what is the difference between A and B? So here we want to find the probability x less than 2. So the difference is here, this one, the first one is x less than equal to. So that's mean the values of x can have 0, 1 up to 2. But here we have x less than 2. So that's mean this is strictly less than. So this is called strictly less than. So that's mean the maximum value of x will be less than 2, not 2. So that's mean the values of x will be, x is 0 and the next value is 1. So probability of x is equal 1. So we have to consider only these two. But for this one, we have three values. Probability of x is 0. You can see here, x is 0, x is 1, and x is also 2 because it was x less than equal, but here we have just strictly less than. So when you will be answering question in the exam or for homework, you have to be very careful about this notation. Okay, so then the probability is, now you can see this probability is equal. Okay, so here you can see probability of x less than 2. So this is equal probability of x equals to 0, x equal 1. So this is 0.5. So now you can also use the CDF function for this one. So how can you use the CDF function? Probability of x less than 2. So we do not know the CDF function for this one, but this can be, you can rewrite this one as x less than equal 1, because the definition of the CDF function is probability f of x is equal probability x less than equal x. So that's why we rewrite this one like this, probability x less than equal 1, because they are same. So this is equal f of 1. So from the table, you can see this is, from the CDF, you can see this is 0.5. Okay. The next one is in part C, we have calculate the probability x greater than equal 1. So how can we calculate this probability? So here we have to calculate the probability where x is greater than equal 1. So to calculate this probability, you can use PDF function. So if you use the PDF function or PMF, then it will be simply probability of x. The minimum value is 2. Then x is equal 3. And the possible values of x are 0, 1 to 3. So in this case, we have only these two probabilities. So if you add them together, then it will be also, this one is from the table 3 over 8 plus this one is 1 over 8. So this is 0.50. Okay, so now you can also use CDF function for this one. But for CDF function, we know the CDF is always less than equal. But here we have probability greater than equal. So we cannot directly use the CDF function for this one. So for this one, first you have to write this one as a complement. So 1 minus probability of, it can be written as either less than 2, because the complement of x greater than equal to is x less than 2. The opposite of x greater than equal to. Okay. Or you can also write this one as probability of x less than equal 1. You can also write like this. Okay. Or so this one is actually 1 minus f of 1. So that's mean 1 minus, and from the table the f of 1 is 0.5, so it will be then 0.50. Do you have any question? Any question? Okay, so the next one is probability of x greater than 2. So x is strictly greater than. So that's mean the numbers of x, the values of x which are greater than 2. So we have just one value which is greater than 2. So that is probability of x is equal 3. So, and this is equal 0. X is equal 3. That means 0.125 from the probability table. And you can also use CDF function. But for this one, it is better to use PMF instead of CDF, because we have just one probability here, probability of x equals to 3. So you can directly get this probability from the PMF table. But for CDF, since this is greater than 2, so first you have to rewrite this one like this, 1 minus, that's mean you have to take the complement. So 1 minus probability of x, the complement of this one is less than equal to the opposite of this one. X is greater than 2, so the opposite will be less than equal to. And we know that this is So 0, actually there is some mistake. This is not correct. So it will be 1 minus 0.875, because the CDF for x is equal to is 0.875. So it will be then 0.125. Okay. And to calculate the probability for this one, either you can use CDF or you can also use PDF function. So for this one, we have, so if you use PDF, so x is between 1 and 3, and 1 and 3 are inclusive. So what does it mean by inclusive? That's mean x can have value between 1 and 3, and x also takes the value 1 and 3. So that's mean the probability will be x is equal 1 plus probability x is equal 3. Sorry, x is equal 2 plus probability x is equal 3. Okay, so now if you so if you plug in the values for this one, and this one, and add them together, then you will have 0.875. Or you can also CDF in this case. So how can we, so this is using PMF, and you can also use CDF. Okay, so in this case, if you want to use CDF, sorry, this is not B, this is 3. So this is equal, we already know that f of 3 minus f of 1 minus. So what does it mean by 1 minus? That's mean the number which are less than, so you can use this notation, 1 minus. So that's mean the values of x which is less than immediate less than 1. So that's mean f of 3 minus f of 0. So and here you can see the probability is 0. So f of 3 is 1, and f of 0 is 0.125. So 1 minus 0.125 is 0.875. Okay, so now we have probability where x is strictly between 1 and 3. So that's mean you have to just consider the numbers which are only between 1 and 3. Okay, so here we have 1 less than 3. X is between 1 and 3. So we have just one number, one value of x, which is between 1 and 3, right? We have just only 2, which is between 1 and 3. It's strictly between 1 and 3. That's mean x will be greater than 1. It cannot be equal 1 here because we do not have the equal sign here, right? Like this, we do not have equal sign. We have just greater than sign here, x greater than 1. So that's mean x will be number which is larger than 1 and less than 3, is smaller than 3. We have just one number in the table which is less than, greater than 1 and less than 3. We have just 2. So that's why the probability of x is equal to will be the probability in this case. So in this case, you can also use CDF function. So to use the CDF function, you can write this one as f of 3 minus, so that's mean you can write f of 2 minus f of 1. So in this case, actually, it is better if you directly use the PMF function instead of CDF function, because if you want to use CDF function, you might get confused here. So it's better to use the PMF function in this case. Okay. So the probability is here 0.375. So why did we use 2 and 1 here? The reason is this one is the number which is less than 3. So less than 3 means the value of x which is less than 3, the maximum value is 2, right? and here minus f of 1. So here we use 1. So since x is greater than 1, so that's mean in this case, we are looking for the probability where x is greater than 1. So this can be written as 1 minus probability of, sorry, we can write this 1 minus probability of x less than equal 1. So the complement is x less than equal 1. Okay. So, and here the probability is 0.375. So do you have any question? Because for discrete probability, for continuous probability, where it is strictly less than or it is less than, where it is strictly greater than or greater than, it doesn't matter. But for discrete case, this notation is really important. So if you have any confusion, you can ask me, because this notation, especially less than equal, greater than equal, for a discrete case, this is really significant, this is meaningful. But for sorry, it was, and also we have so I use the same notation here. So less than greater than, okay. But for continuous case, whether it is less than or less than equal, the probability will be same, or greater than equal, the probability will be same. There will be no difference. But in discrete case, the probability will be different. They are not same, and you have already seen this. The probability is different for less than and strictly less than. So if you go back to the first example, so part A and part B, you can see that here the only difference is this is less than equal and this is strictly less than. And you can see this probability is 0.875 and this probability is 0.50. So that's mean they have different probability when we use different sign, less than and less than equal. So that's mean in discrete case, this is really important. This is meaningful. But in continuous case, they will have the same probability whether it is less than or strictly less than. So why in continuous case it doesn't matter? I'll discuss this one in the next chapter, in continuous random variable and its distribution. So in section 3.3, this is about the expected value of random variable. So what is the expected value? So that's mean the value we expect for the average value we expect for the random variable x. So this is called the expected value. So that's why the expected value is actually the population mean. So for example, if we think if x represents the scores of students in an exam, then the expected value x is the average score of the students, of the total students. So that's mean the expected value of random variable is actually the population mean. So, and the population mean is denoted by mu. You already know this notation. This is called mu, which is actually the population mean. So the expected value of, if x is random variable, the expected value of x is actually the mu, which is the population mean. But here we used mu sub x. Here we have subscript x. So why do we have subscript x? So sometimes you can have two different random variables in one example. For example, if you have two random variables, x and y. So x is the height of the students and y is the weight of the students. So that's mean the mean height and mean weight will be different, right? Because they are different random variables. So for example, if you have two random variables and if you use this notation mu, then for example, expected value of x is mu. Then what will be the expected value of y? So if you also use mu, then it is not correct because we already used mu for expected value of x. So that's why to differentiate um, the means of two different random variables, we use this subscript. So mu sub x. So that's mean this is the expected value or this is the mean of x. And in this case, you can use mu of y, mu sub y, mu subscript y. So that's mean this is the mean of y. So here this notation is for mean, this is for population mean. So we used here x to indicate that this mean is for random variable x. So expected value of x is mu x, and the expected value of x for the random variable, discrete random variable, is summation of x times f of x. So what does it mean? That's mean you will multiply the value of x with the corresponding probability, and after multiplying all the values of x with their corresponding probability, you will add them together, and that's the corresponding and that's the expected value. So here you can see in the next example, you can see here we have, so forget about this column. So if you look at the first two columns, then you can see we have one random variable and we have f of x, which is the PMF of x. So how do you know that this is a probability distribution? There are two ways. One way is if it is mentioned in the problem that this is a probability distribution. And the other way is we have possible values of x and all the corresponding values, these values, the functional value or f of x is between 0 and 1. And the total probability, if we add them together, it is 1. Okay, so if you are given a table here, for example, x, and this is f of x, and you have here 0, 1, 2, 3. Here we have 0, 1, 2, 5, 0, 3, 7, 5, 0, 3, 7, 5, 0, 1, 2, 5. So if you are asked in the exam, or if you are asked, is it a PMF? So how do you answer this question? Okay, so there are two things. You have possible values of x, 0, 1 to 3, that's fine. And you have the corresponding probability here. So first thing is all the numbers for in this column should be between 0 and 1. It cannot be less than 0, it cannot be greater than 1. So it will be always between 0 and 1. And if you add them together, so if you add all of them, then it will be exactly equal to 1. If this table doesn't satisfy these two conditions, then it is not a PMF. It is not a probability mass function. Is it clear? Okay, so now let me give another one where we have x and we have f of x. Suppose we have 0, 1, 2, and we have, for example, we have 0.75, 0.5, and negative 0.25. So is it a PMF? If we add them together, if we add all the three numbers, it is equal to 1. That's correct. Is it a PMF? No. Okay. So I got one answer. No. So could you please tell me the reason why it is not a PMF? Yeah, because it is negative 0.25. So when x is 2, the f of x is negative 0.25, which is not correct, because f of x will be always between 0 and 1. Yeah, thank you. So this is not a PMF. So this is not a PMF. The answer is no. And for this one, yes, this is a PMF because all the values are between 0 and 1, and the total probability is 1. So this is the first one is a PMF, but the second one is not a PMF. Okay. So let's go back to the expected value. So here we are given a PMF and we have the values of x and we have the values of f of x. To find the expected value, the expected value of x means summation of x times f of x. So, and you will sum over the possible values of x. So here x is from 0 to 3. So you can just write x is equal 0 to 3. This is 3. Yeah. So x is equal 0 to 3. So that's mean the first value of x is 0. So that's means 0 times f of 0 plus 1 times f of 1 plus 2 times f of 2 plus 3 times f of 3. So the expected value of x is equal summation of x times f of x. You will multiply the value of x and its corresponding probability, and you will do it for each possible values of x, and you will add them together. So this notation means you will consider first x is equal 0 and up to 3. So x is 0. So 0 times f of 0 plus 1. The next value is 1. 1 times f of 1. The next value is 2. Then 2 times f of 2 plus the next value is 3. So 3 times f of 3. And here we have the maximum value. So this is the maximum value. And this is the minimum value. Okay. So we have also done this here. We multiplied x and f of x. So 0 times 0.125 is 0. 1 times 0.375 is 0.375. 2 times 0.375 is 0.750. And 3 times 0.125 is 0.375. So if you add them together, the value is 1.50. So the mean value is 1.50. So this is the expected value of x. So what does it mean by expected value of x here? So what is x here? X is the number of tails obtained in 3 flips. So the expected value means here, so the if you do this experiment several times or thousands of times, the expected number of times the 3 tails, the expected number of times the tails will occur is 1.50. The average value of x is 1.50. So that's mean the population mean is 1.50. So that's mean if you flip a coin 3 times, we expect tails to appear 1.5 times out of 3. Do you have any question? Okay, so we discussed the expected value of the random variable x. So now you can have expected value. You can also find the expected value of the function of x. So here we just found the expected value of x. for example, if you want to find the expected value of 2 times x, so this is the function of x, you can also find the expected value of 3x plus 1, or you can also find the expected value of 3x squared minus 2x plus 1. So sometimes it is really important to find the expected value of the function of x instead of just the expected value of x. So that's why we need to know how to find the expected value of the function of x. So this is actually the definition is same. So expected value of h of x. So this is the function of x. This is actually summation of h of x times the probability mass function PMF. So in case of x, it was expected value of x was x times f of x. So that's mean x times this is probability function. So similarly for any function of x, the definition is same. It will be summation of this one, the function for which we want to find the expected value, times the PMF or PDF. Okay. So now we have one example here. So an appliance dealer sells 3 different models of upright freezers having 16, 18, and 20 cubic feet of storage space. And X is the amount of storage space purchased by the next customer to buy a freezer. So X represents the amount of storage space. So, and there are 3 different values there are and 3 different type of freezers. So here 16 feet space, 18 feet, or 20 cubic feet of storage space. So there are 3 different models. So that's mean the possible values of x are 16, 18, and 20. So the possible values for x are 16, 18, 20. So, and we have their corresponding probability. The probability when x is equal 16, this is 0.2. When x is 18, this is 0.5. When x is 20, this is 0.3. So this is a PMF. It is already said here in the question, mentioned here in the question, that it is a PMF. Or if you add the probability together, 0.2 plus 0.5 plus 0.3, if you add them, it will be equal 1. So you can say this is a PMF. We have the possible values of x, and all the numbers for f of x are between 0 and 1, and total is 1. So that's mean this is PMF. So this is a probability mass function. And the possible values of x are 16, 18, and 20. So now we have to calculate the expected value. So expected value, that's mean the expected storage space purchased. So that's mean we want to find the expected value of x, and which is equal summation of x times f of x. So we have only 3 possible values. So the first one is 16. So it will be 16 times f of 16 plus, next one is 18 times f of 18 plus 20 times f of 20. So then 16, f of 16 is 0.2 plus 18 times f of 18 is 0.5. So it will be 0.5 plus 20 times 0.3. So here we actually we have this multiplication here. This one times this one is 3.2. So 18 times 0.5 is 9, and 20 times 0.3 is 6. So if you add them together, then it will be 18.2. This is 18.2. So the expected storage space will be 18.2 cubic feet. Okay, so in part B, if the price of the freezer capacity of a freezer capacity x cubic feet is, okay, so the price for x cubic feet is 70x minus 65. So what is the expected price paid by the next customer to buy a freezer? So here we do not want to find the expected capacity. So we want to find the expected price. So the price for the expected x cubic feet is 70x minus 650. So which is the function of x. And we want to find the expected value of the price. So that's mean we want to find the expected value of this function. Okay. So actually, there are two ways to find the expected value of a function of x. One way is, so I already said that this is equal the function of x times the PMF of x. Actually here this notation is, this is not actually f of y. This notation is not correct. It should be f of x actually, yeah, and y times this should be actually f of x, because we are multiplying with PMF, not f of y. And if since our PMF is here f of x, so you have to multiply with f of x. So we are multiplying the function with PMF. So one way is you will calculate, so we have three values here, so you can just plug in all three values here. So first one is then 70 times 18 minus 650 times f of 18 plus, similarly you can plug in x equal, sorry, first one is 16 actually, yeah, this is the second one, yeah, it should be 16, first one is 16. So you can plug in all three numbers for x here and you can add them together. Okay, so another way is, first you can calculate the value of the function. For each value of x, you can calculate the value of the function. So if you plug in 16, then this will be 470, 70x minus 650 will be 470. If you plug in 18, then it will be 16. If you plug in 20, then it will be 750. Now you have to multiply this number with corresponding PMF. So when x is 16, the PMF is 0.2. So you will multiply this to number, you will multiply this to number which is 94. And for this, you will multiply this to number which is 305. You will multiply this to number which is 225. And if you add them together, then it will be 624. So the expected price will be $624. So that's mean the next customer purchase the freezer whose expected price is $624. Okay. There is another way to calculate this expected value. So if you already have the expected value of x, you can just use that number to calculate the probability. So the properties of the expected value is, if you have a linear function of, or any function of x, then you can simply write this one as expected value is distributive over addition or subtraction. So that's mean you can distribute expected value over addition or subtraction. So here we have ax plus b. A is a number, b is another number, and x is random variable. So you can simply write this one as ax plus expected value of b. And you can write, so the expected value has very nice properties. So the first property is, if a is a number and x is random variable, a is any real number, a is any number or any real number, then expected value of ax is equals just a times expected value of x. For example, if you have expected value of 3x, so expected value of 3x is you will multiply x with 3 and then you will calculate the expected value of this one. Or you can also write this one as 3 times expected value of x. That means you can simply calculate the expected value of x and you can multiply with 3. So for expected value, if you have a number inside the expected value as a multiplication, you can just take it outside the expected value. So expected value of 3 times x is just 3 times expected value of x. Similarly, expected value of, and this is true for any number. So now you can apply this property here. So expected value of ax, so a is a number, so you can just write a times expected value of x plus. So in this part, we do not have the random variable, right? So what is our random variable here? So what is our random variable here? In this case, x plus b. So which one is random variable, a, b, or x? Anyone? Yes, I get one answer. Yeah, x is random variable. Thank you. And a, b are some number. It could be any number, any real number. Okay, so the expected value has another property. If b is just a number, the expected value of b is b. And for example, if we want to find the expected value of 3, this is 3. So the expected value of a constant, of a fixed number, is always equal to that number. This is always true for any number. This is true for any number. So if you do not have the random variable with this number, so here we do not have the random variable, right? We have just the number. We have just one number. So expected value of this one is just that number. So this is a very nice property of the expected value. So now you can see here b is just a number. We do not have any random variable here, right? Because the random variable is x. So this is equal just the number b. So we can just write expected value of b is just b. Okay, so now go back to the example. So we wanted to find the expected value of the price of the refrigerator, which was 70x minus 650. So we can write this one as expected value of the first number, and we have minus here, and the expected value of the second number. And we already know this is equal, since 70 is just a number, we can take 70 outside, the expected value, minus, this is just a number, so we can just write this is equal to 650. So now you can see we have 70 times expected value of x minus 650. So you already have the expected value of x in part A. So you already have the expected value of x here. So you can just use this number to find the expected value of this function. So you do not need to calculate these values, right? So it will save your time. So you can use this property, or you can directly calculate the number, and then you can use the formula for the expected value, and then you can find the expected value. But I will suggest you to use these properties to find the expected value of a function of random variable. Do you have any question? Okay, so if you do not have any questions, so we'll go to the next term, which is variance of x. So if x is a random variable, so you can calculate the variance of x. So the variance of x is just the formal definition of this one is actually expected value of x minus mu square. So the variance is actually the expected So the expected squared deviation. So why is expected squared deviation? So we are finding the expected value, and what is the function in the inside of the expected value we have? We have x minus mu. So what is mu here? Mu is the expected value of x. Mu is expected value of x. So that's mean this is also called mean. This is also called mean of the random variable. So what we are doing here actually, we are finding the deviation of x from the expected value. So how far the value of x is from the expected value, right? So we are finding the x minus mu means we are finding the deviation from the expected value of x. That means we are finding the deviation of x from the expected value or from the mean of x, right? And then we are taking the square. And after that, we are taking the expected value here. So that's mean the variance is the expected square deviation from the mean. This is called the square deviation from the mean, and we are finding the expected value. So the variance is actually the expected square deviation from the mean of the random variable. Okay. So now how can we find this expected value? Okay, so the one way is this is also a function of x, right? X minus mu squared. Mu is the expected value. So you can calculate the expected value of x. And this is also function of random variable x. And this is the expected value of the function of random variable x. So you can simply find by using this one, the function of x times the PMF. So you can use this formula, but sometimes it will not work or it is very time consuming. So we can also rewrite this formula as this is equal actually. We can also write this formula as this one. We can write this one as expected value of x squared time minus square of the expected value of x. Actually, you can derive this formula from here. So I can also show you the derivation. So okay. So expected value of x minus mu square. So this is actually expected value of, first you can use the formula for this is actually, you can use this identity a minus b square. So this is equal a square minus 2ab plus b squared. So you already know this identity from college algebra class. So here we have x minus mu whole square. So you can just write x square minus 2x mu plus mu square. Now you know the property of expected value, the distributive property. So you can distribute to each number. So minus expected value of 2x mu plus expected value of mu square. So this is expected value of x squared. So you will keep this one as it is minus, you already know if you have some numbers multiplied with a random variable, and if you want to find the expected value of that one, so you can just take out all the numbers except x. So we have 2 here, we have mu here. So we can take out 2 and mu. So then we'll have expected value of x. Plus, this is just a number. Mu square is mean. We do not have x here. So you can also just write this one as mu square. Is it clear? Any question? Okay. So next we can write expected value of x square minus 2 times mu. So what is the expected value of x? So what is expected value of x? Can we relate the expected value of x with mu? Anyone? Yes, they are same. Thank you. So expected value of x and mu are same. So we can just plug in mu here instead of expected value of x because they are same. Plus mu square. So now we can write expected value of x square minus 2 mu square plus mu square. So we can also write expected value of x square minus, here we have negative 2 mu square, we have 1 mu square. So we can just write minus mu square. So what is mu? Mu is also expected value of x. So we can simply write expected value of x square minus mu is expected value of x. So we can write expected value of x whole square. So this is actually, we use this formula to calculate the variance. So this is actually the variance of x. So we use this formula. So this is the formal definition of variance. And this is actually the calculating formula. We use this formula to calculate the variance of x. Okay, so yes. Okay, so now you can see we derived this formula here, expected value of x square minus mu square, and x mu is expected value of x, so it will be expected value of x square minus expected value of x whole square. Okay, so the standard deviation of x. So what is the relation between standard deviation and variance? Standard deviation is the square root of the variance, right? So that's mean variance is this one. So the standard deviation will be square root of expected value of x square minus mu square. So for to denote the standard deviation, usually we use sigma, but here we use sigma x to represent, to indicate that this is the standard deviation of random variable x. So now we'll go over an example here. So we have flip of 3 coins and we already know the probability distribution. So this is the probability distribution. Now we have to find the variance of x and the standard deviation of x. So to find the variance of x, we already know variance of x is equal expected value of x square minus mu square, or you can say mu is where mu is expected value of x. Okay, so to find the expected value of x square, so this is also function of x. So we can also just write x square times f of x. So that's mean you will consider each value of x and you will take the square of that one and multiply with f of x. So that's mean how you calculate this one, 0 square times f of 0 plus 1 square times f of 1 plus 2 square times f of 2 plus 3 square times f of 3. So now you can just plug in all the numbers for f of 0, f of 1, f of 2, and f of 3, and you can multiply and add them together. And finally, you will have this one. This is x squared times f of x. So you will have 3. So expected value of x squared is 3 minus, so this is equal 3. So minus expected value of x, we already calculated this one, this is 1.5. So minus 1.5 square. So the variance is then, the variance will be 0. If you simplify this one, then it will be 0.75. So the variance is 0.75. So how are you going to calculate the standard deviation? A standard deviation is the square root of the variance. So that's mean a square root of 0.75. So the square root of 0.75 is 0.86. So the standard deviation is this one. So variance is equal 0.75 and standard deviation is 0.86. So that's how we calculate the standard variance and standard deviation for discrete random variables. So we have another example for the refrigerator example, or the freezers example. So here we have the probability distribution. So we want to calculate the variance. So to calculate the variance, first you have to find the expected value of x squared. So which is x squared times f of x. So that's mean 16 squared times f of 16 plus 18 squared times f of 18 plus 20 squared times f of 20. Now if you simplify this one, then the expected value of x squared will be 333.2. So it will be then 333.2. And we already know the expected value of x. So the variance will be then expected value of x squared, which is 333.2, minus expected value of x squared. So that's mean 18.2 squared. So if you simplify this one, then it will be 1.96. And since this is a standard deviation, so it will be a square root of 1.96, and which is 1.4. Okay, so here the variance is equal 1.96, and standard deviation is equal 1.4. So that's how you calculate the variance and standard deviation for the discrete random variable. So the next section is about binomial distribution, and the last section about the Poisson distribution. So I think we do not have enough time to discuss about that. So we're not going to start a new section right now. So I will stop here.